Hello, remote students. I wanted to go over the answers in the book with you so that you could check and see how well you were doing in understanding what you've read. Remember that whenever you see a key idea, I would highlight it so it jumps out of the page. Also, the definition of a bold-faced word. Just simply put, velocity is just the speed of an object, but it also includes direction. So if you were traveling 75 miles an hour on Interstate 80, in order for you to show the velocity, you would have to say I'm traveling 70 miles an hour on 80 east or 80 west. Science uses velocity over just speed quite often. If you identified the supporting evidence, why is velocity is important, that an error in determining velocity could lead to a collision is what I underlined. Same thing with this one down here. Why would velocity be important? I believe these are the Blue Angels, I believe they're called, and they fly apart and they fly together and they fly relatively close. And one mistake, somebody goes left instead of right when they're supposed to. Once again, there could be a collision. In calculating velocity, this part here was a little confusing. I took my ruler and the question asked me, after I read the word problem, the question asked me to use a metric ruler to determine how far west and how far south he has to travel. So the question wasn't clear to me about whether they wanted me to write the answer in centimeters or meters. They gave me the conversion here, but just to be safe, I did both. So when I measured here, I got 7, and down here I got 3, so that was 10 centimeters west, which would then calculate to 1,000 meters, and then doing this I got 6, which would be 6 centimeters south, or 60 meters, which is a total of 1,600 meters. I don't know if you can see that. It is written in pencil. So when I calculated here, this was really a little bit tricky. He has 5 minutes to travel 300 seconds. Oh, wait a second, because he had 5 minutes. Well, excuse me, he had 5 minutes to, which converts to 300 seconds. I misspoke there. So what I did was I took the total number of meters divided by seconds, and he would have to travel 5 meters per second on his bicycle, which would be relatively easy. Down here, let's see if I can scroll out here again so you can see the book, that I have that, how do you describe the motion of an object? Obviously we can use its speed and its direction. Now I get it that velocity of an object is speed and direction, so you can get that these 2 pages really wanted you to understand that velocity is just speed and direction. It's nothing, what I would say, something new. So we're going to be spending some time on graphing motion, and simply put, I want you to be able to look at a graph like this and know that this person is traveling at a constant speed, that this person started at a speed, then they came to a stop, and the reason why you know it's stopping is because it's a horizontal line. In other words, you can't really stop time, but this person stopped increasing their distance. And since this is a little, what 6th graders would refer to as more steep or steeper, that's basically just speed. So this person ended up going faster than perhaps that they started. So this, a lot of talking about what slope is. Slope is just when you're looking at the steepness of the line, that is actually calculating speed. Don't get too nervous. I'm not going to really test that. That slope is rise over run. So if you look at how this line would rise, that would be distance. Let me write that up here, and that would be distance. And the run is down here, which is the time, which is distance divided by time, and that equals speed. So this kind of stuff is really nothing new. It's just how to interpret speed using a graph from the book. So let's go through and just check, make sure that you've highlighted that blue idea, the definition of what this is here, how you can find it here. You know, it is just division here. So over here it says, what is this jogger's speed? You don't really even have to figure this out because it gives you what the slope is, which is 200 meters. So this person is 200 meters per second. Now on the same graph, it says draw a line that represents the motion of a jogger that's going 100 meters per minute. So I think it's really important to put the dots on first. So in 1 minute, oh, is that minutes? Oh, sorry, darling. This is 1 meters per minute. Okay, so over here it's 1 minute. And since this first white line is 200, I'm going to put it halfway. And then, so at 1 minute, he would be at 100 meters. At 2 minutes, he would be at 200 meters. At 3, he would then be at 300. So this person is traveling about half the speed of the other one, and you can maybe connect that line. Let me see if I can do this here, just partially. And you could notice that the slope here is not as what sixth graders would call steep, so it's not as fast. But a lot of sixth graders look for patterns, and they would jump right on putting them in the corners of the boxes, but you don't put it in the corner of this box here. So double check that and make sure that the slope of the second jogger would be not as steep or not as high as the first jogger. So let's go over here and see if we could figure this out. Now, what I calculated was, it says here to find the rise and the run and the slope for each segment of the graph. So I thought they talked about this segment. So since I know that the rise, which is how much this is here, would be the distance, so I went from 0 to 600. So I wrote 600 here. And then the run would have been from here to here, which would have been 4 minutes. So then when I divide that, I get 150 meters per minute. Now the answer in the book calculated each individual box. So they said this answer, the rise was 150. And that each segment was only 1 minute. So we would still get, since we still are dealing with the same line, 150 divided by 1 would be 150 meters per minute. Same thing with this one. I did, okay, obviously this person has stopped because what's the rise? They're not going anywhere. What's the run? I went from 4 minutes to 7. So that would be, the run would be 3. So the slope would be 0 meters per minute. They did a 0 and a 1 and still came up with the 0 because each little segment of the graph. Here, the rise and the run, the rise, how much does it go up? I did, it went from 600 to 1200. So the rise would be, it went up 600 meters. And I'm going to guess that the answer in the book, it went from 600 to 800. The answer in the book is probably going to be 200. So the run for me, since I did all of it, would be from 7 to 10, which would then be 3. So then 600 divided by 3 would be 200 meters per minute. And they did, here would be 1 and got the 200 meters per minute. So they did each little box. I did the segment of the line, I guess, but the slope or the speed would be the same because that's the steepness, like I said, of the line. So we're going to spend some time interpreting the motion of graphs this week. So even though we're done with this section, We might be doing some of the review pages, but let's look at this. The slope of a distance versus time. Notice that the time is always written on the horizontal one. The rise of a line on a distance is 900 meters. I think I can figure out that that's distance, and the run is 3 minutes. What is the slope? So 900 divided by 3 would be 300 meters per minute, which is actually the speed also. Let's see here, apply concepts. Is it possible for a distance and versus time graph to be a vertical line? And absolutely not, unless you can vaporize or transport yourself somewhere. Think about, if 1 second, can you be in the same moment of time almost in 2 different places? So maybe that's fodder for science fiction. So if we got into the transporter, within 1 second, you could transport yourself down on the planet. But right now, no, it's not. You can't be 2 places at one time. At one moment or in time. I'm just going to leave it like that. Okay, now I know to show the motion of an object on a line graph. You plot points and draw a line. So let's see if we can, we're going to step this up a little bit. This is a main standard in 6th grade, is to be able to look at speed or look at distance and time and be able to graph it. So that's what we're going to spend some time this week. All right, you guys, have a nice Monday.